Okay, let's get started here. So today we are going to begin our discussion on asset pricing. Asset pricing is basically a model of risk and return. On the right hand side, you have some measure of risk, and on the left hand side, you have your expected return. So you're getting a precise relationship between risk and return. You all are familiar with the capital asset pricing model, CAPM. You have learned about it in 320 and perhaps other finance classes as well. CAPM is an example of an asset pricing model. So the risk metric in CAPM, as you know, is beta. So on the right hand side, you have beta, and you have expected return on the left hand side. So it's basically the relationship between beta as a measure of risk and expected return. So in this discussion, we are going to talk about CAPM, but we are also going to look at some other asset pricing models as well. All right, so let's first look at some of the assumptions that are built into a capital asset pricing model. So the model has number of assumptions. Some of those are clearly unrealistic, and that is one of the criticisms of the model, that it is built on all this unrealistic assumptions. The issue there is that if we sort of incorporate all real world complexities into the model, it would basically become very difficult to come up with a model. It would be mathematically untractable. So we have to simplify things, but then what we can do is, once we have the model, we can take it to the real world data and see how well the model works with the data. All right, so let's look at these assumptions here. The one of the assumptions is that markets are competitive. Investors are basically price takers in the CAPM setting. What that means is that no single investor can influence the price of the securities, right? The investor might be wealthy, but not wealthy enough to actually impact the price of securities. Also, information is readily available and it is available for free. So anybody can get any information that they need for their analysis for free without incurring any cost. No taxes, no transaction costs. So that is one of the assumptions that we have to make. Clearly, not something that we see in real world, but we need this for CAPM to work. We also require that you can borrow and lend at risk-free rate and in unlimited quantities. Okay. Then there is this assumption of what we refer to as homogeneous expectations. And what that means is that all investors are similar in terms of their expectations, right? So they have same estimates of expected returns, same estimates of risk, same correlations, standard deviations, and so on. Everybody has same estimates, right? So they are identical in that respect. What they differ in, though, is in terms of their initial wealth and in terms of their risk preferences. Not everybody has same risk preferences. There are some investors who are more risk averse, others who are less risk averse. All right. So this is an important assumption in CAPM because as you will recall from our discussion on diversification, uh, if investors hold the same portfolio of risky assets, then that portfolio has to be the market portfolio, right? So one of the key things that comes out of that analysis in diversification is that the best portfolio for all investors is the market portfolio, right? Everybody holds the market portfolio as their optimal risky portfolio, and this is also one of the key assumptions built into CAPM. And for everybody to arrive at that same portfolio uh, uh, of risky assets as their optimal portfolio, they obviously need to have the same inputs of risk and return, right? So that is basically this assumption of homogeneous expectations. Now, CAPM is a one period model, meaning, there is no sort of feedback kind of thing here. You just have a beginning and an end, a single time period. And what we are trying to do is we're basically trying to do mean variance optimization, meaning that we want the highest expected return with lowest possible standard deviation, or we want the highest Sharpe ratio. All right. Okay, so those are some of the assumptions for CAPM. And then with those assumptions, when you do the analysis, you arrive at certain equilibrium conditions. So what we can conclude or infer from this analysis is that first of all, as we already talked about, all investors would find the market portfolio to be the optimal risky portfolio. And by market portfolio, we mean the entire market, right? So all securities, stocks, bonds, other types of risky assets, everything that is included in the market is part of this portfolio. So that is the best portfolio for investors, and investors would basically find this portfolio on the efficient frontier, that is their optimal risky portfolio. Okay. So here is a graphical depiction of that. I mean, this again relates to the analysis from chapter 6. Uh, the optimal portfolio is the tangency portfolio, and now we have labeled that portfolio as M, which is the market portfolio, right? And now our capital allocation line is the capital market line, right? When you have market portfolio as your risky portfolio, the capital allocation line has a special name. We refer to this as the capital market line. Okay. So what happens with all this analysis, and what we sort of arrive at in the end is that the risk in CAPM is proportional to risk premium. All right. Now we have to talk about risk here. So far, our risk metric has been standard deviation, but standard deviation is not the right risk measure to use in CAPM. Why? Because there is risk return trade-off, right? So when we say that investors should be compensated for risk, the question is, what type of risk should investors be compensated for? We talked about two types of risk. One is the market risk, right? That is basically risk related to macroeconomic type of factors, interest rates, business cycles, recessions, expansions, and so on. So that is the risk that cannot be eliminated, right? That is non-diversifiable. The other risk is firm specific risk, and that risk is diversifiable. That is risk related to individual firms, unique for the firms. Should investors be compensated for market risk or firm specific risk, or both, right? That is the question. And the answer is that investors should only be compensated for market risk, not firm specific risk. Why? Because you can get rid of firm specific risk uh, through diversification. And in the CAPM setting, based on these assumptions, you can buy as many securities as you want. You can create a well diversified portfolio without incurring any cost, right? There are no transaction costs, there are no tax considerations. So you can easily create a well diversified portfolio and get rid of your firm specific risk without incurring any cost. So you should not be compensated for that component of risk. The risk that you should be compensated for is the market risk. Now, sigma, or a standard deviation that we have talked about so far as a measure of risk, it's a total risk measure. It includes both firm specific risk and market risk. Sigma is basically just capturing the fluctuations in returns, right? The variability or the volatility in returns, and returns can be variable due to firm specific factors or market factors, right? So sigma is a total risk measure, but since we only want the market risk in CAPM setting, we need a new risk measure, and that's where beta comes into picture. So beta is basically the systematic risk measure, right? It's basically looking at how the return of the individual security or an asset is related to the market, right? So market portfolio, it's basically a well diversified portfolio, since it includes every single asset out there in the market. And how sensitive the return of a security is to the return on the market portfolio will in turn tell us how the security is responding to market-wide risk factors, and therefore that can be used as a measure of securities market risk, right? So that's where beta comes into picture. So again, if you recall from your earlier CAPM discussions from 320, you'll know that beta measures the sensitivity of securities return to the market return, right? Higher the sensitivity, greater is the beta. So for example, if market return is 1%, and on average the security goes up by 2% when the market goes up by 1%, then the beta is 2, right? And so on. Similarly, if the market falls by 1%, then that security with the beta of 2, we can expect it to go down by 2%, right? So it is very sensitive to market movements. It has higher market risk. Okay, so beta is going to be our measure of systematic risk, and that is what is relevant for CAPM. Okay, so in the CAPM world, with all this assumptions, the inference is that beta is directly proportional to risk premium. All right, beta is proportional to risk premium. If you recall from our earlier discussion in chapter 5, risk premium is basically compensation for risk, and how we define it is basically expected return minus the risk-free rate, right? So for example, if the risk-free rate is 2%, right? So what that means is that without taking on any risk, you can earn a return of 2%, right? And then you have a stock with an expected return of say 5%, right? So the risk premium for that stock is 3%, right? 5% minus 2%, and that's extra 3% is your compensation for risk. You expect this extra 3% return as a compensation for risk, right? So risk premium is expected return minus the risk-free rate, and in CAPM, the risk premium is directly proportional to beta, right? There is a direct linear relationship between beta and risk premium, right? So let's actually go to the whiteboard and see what that exactly means, that proportionality, and how we can actually get to the CAPM relationship based on this result. Okay, so so let's say you have some beta values here, and then you have the risk premium, right? Risk premium is again expected return minus the risk-free rate. All right, so let's say you have a beta of 1, right? For a beta of 1, let's say the risk premium is 5%, right? So what direct proportionality means is that if I have a stock with a beta of 2, its risk premium would be 10%, right? So double the beta, double the risk premium. If I have a security with beta of 0.5, its risk premium would be 2.5%, right? So there is a direct proportionality here, right? Greater the beta, proportionately higher is the compensation for risk, right? So another way to think about this relationship is that if I take the ratio, right, expected return minus risk-free rate, so my risk premium divided by beta. If I take the ratio of those two, what can I say about that ratio? In this example, as you can see, that ratio is always 5, right? 5% over 1, 10% over 2, that is 5, 2.5% over 0.5, that is also 5. So that is another way to sort of state this idea that a risk premium to beta is constant, right? For any security or for any asset, any portfolio, if we take the ratio of risk premium to beta, it would be the same number, right? That is what CAPM tells us. So we can use that idea to actually arrive at the CAPM relationship. So let's say you have two securities A and B, right? So what I can say is that let's yeah, expected return for A minus the risk-free rate divided by beta of A, it should equal what? Expected return for B minus the risk-free rate divided by beta of B, right? Any two securities or assets or portfolios you take, this ratio of risk premium to beta would be same, right? Like in our example, that ratio was 5. All right, so this is the starting point. Now, our market portfolio is also a risky portfolio, so this relationship would hold for our market portfolio as well. All right, so let's say instead of this security B that I have, let's write this down for the market portfolio. I'm going to denote the market portfolio by M. All right, so so I'm basically going to replace B by M here, and we'll keep the asset A. So we are looking at asset A and the market portfolio. So what would that relationship look like in that case? uh, so you have expected return of A again minus the risk-free rate plus beta of A, and then on the right hand side here you have expected return on the market portfolio minus the risk-free rate divided by the beta of market portfolio, right? So market portfolio is a risky asset, so this relationship should hold for the market portfolio as well. Now, beta of market portfolio. What is the beta of market portfolio? Remember, we said that beta measures how sensitive the return on a security to the market movement, right? If market goes up by 1%, security goes up by 2%. In response, we say that the beta is 2. So given that idea, what should be the beta of the market portfolio? The beta of the market portfolio is 1. It's like measuring the sensitivity of market to itself, right? So beta of market portfolio is 1. That means the denominator here on the right hand side is 1. I can write this beta as 1. So I can basically get rid of this denominator here. So let me do that. Right, erase this beta here, and this is what I'm left with, right? Okay. So we have expected return on A minus the risk-free rate divided by beta of A equals expected return on the market minus the risk-free rate. And now all I need to do is I need to just sort of rearrange this, and you will get your familiar CAPM equation. All right. So multiply both sides by beta A. So what do you get? Expected return on A minus the risk-free rate equals beta of A times ERM minus RF, right? And then next step, add the risk-free rate to both sides and you get your CAPM equation. So let me do that on another whiteboard. So expected return of A equals risk-free rate plus beta of A times ERM minus RF, right? So hopefully you recognize this equation. This is your CAPM. This is CAPM, right? Beta of the security. So beta A is related to the expected return on the security, risk-free rate plus beta times the market risk premium, right? This is the market risk premium in the parenthesis here on the right hand side, ERM minus RF, right? That is your familiar CAPM relationship. All right, so that's the capital asset pricing model. You can actually verify, do like a quick check to make sure that this relationship actually uh, works as intended. For example, when I have a beta of 0, right? If I plug in beta of 0 into this equation, what do I get? I get expected return equals risk-free rate, right? Beta equal to 0, that basically eliminates the second term here, and I get expected return equals risk-free rate. And that makes sense. If you have beta of 0, that means that asset is risk free, right? So its return should be the same as the risk free rate of return, right? What if I have beta 1, right? If I plug in beta 1 in this equation, what do I get? With the beta 1, I will get ERA equals RF, right? Plus beta is 1, right? So all I'm left with is ERM minus RF, right? And then this RF and this negative RF cancels out. And what do I get? ERA equals ERM, right? Expected return on the security A is the same as the expected return on the market if its beta is 1. And again, that makes sense, right? If security has the same beta as the market, right? Remember, market has a beta of 1. So if you have a security that has the same beta as the market, same risk, so it should have the same expected return, right? So you can do like this type of a couple of checks to see that the relationship is valid. All right, so let's go back to our slides here. On the slides I have this same example. um, Same thing worked out here. It uses del as an example, right? So instead of RA you have RD, but essentially it's the same thing, right? So you get expected return minus risk-free rate for del divided by beta equals expected return on the market minus risk-free rate, and then you rearrange that and you get the CAPM equation. Okay. All right, so next thing that we are going to look at is basically the plot of CAPM, right? How can I draw a graph of beta against expected return? That plot is actually known as the security market line. All right, so we'll look at the graph next.